Hi class, we're going to take a look at Introduction to Probability, which is 5.1, and we need to talk about a couple of actual definitions. Now, within the definitions in this section, we're going to be looking at events. And events are basically defined as anything that's going to actually occur. And we're talking about future procedures that are actually going to happen. So for your events, you're typically going to use capital letters, typically A, B, type of letters for any of the events, and all of the events need to be declared because a problem could first say, well, let's take a look at the distribution of the ones, the sixes, depending on what event they're talking about. So we need to see what exactly is being defined as A and B. So all of your problems with probability, you're going to be declaring a variable, which is going to be a particular scenario. Now, the next definition that we need to talk about is the universal set or the sample space. And basically for the sample space, this is referred as all possible ways that the event in question can actually occur. So for example, if you're looking at tossing a die, well, this is your sample space. You technically have a total of 6 possibilities, assuming that you're working with numbers 1 through 6. When you define the probability of an event, this is the notation that we're using. So it's contradicting the algebra in terms of the way that we write it, but it's going to be a P of A once we define the event. And that's going to be the ratio of these two. So total numbers that the event can occur over the sample space. As you're taking a look at this outcome, you're looking at your probability only being between those two, meaning between 0 to the values of 1. And all the problems are okay to express them as rounding to 2 decimal places unless they stated otherwise. But all of them will be asking for decimals. Some problems are going to be requiring percentages. But so if they don't require percentages, leave them as a decimal. That's perfectly fine. Now, some definitions that are from the past, and this is related to technically what we did on the empirical rule. So when we refer to probability, in this case, if they were to mention anything about the event being unusual, you're going to be look at any event that has a chance of less than 5% to occur. So if you have the probability of 0.5 or 5%, if it's anything less than that, you would be calling it unusual. Now, some of the technicalities on the problems and the vocabulary, it's very confusing in probability. Sometimes they're asking for a specific event and others are going to be asking for the event not occurring. So if they mention the complement, this is technically all the outcomes that the event is not going to happen or occur. So for example, in this example here, you're looking at event A being a 5 or a 6. The complement of A is basically all the other ones. So as you're working on problems, you have to basically be very careful and read them. Read the problems to make sure that what are they asking, because sometimes they're asking about the complement and they'll just mention find the probability that an event will not occur. So at the moment that they mention not occurred, then they're referring to the actual complement. The notation is A bar or A prime. Another definition that is going to show up, and this is going to come in one of the labs, is the idea of the law of large numbers. Now, in the idea of the law of large numbers, you're looking at the following. And if you evaluate the probability of tossing a coin and obtaining heads, in this case heads, the probability of heads is about 50%. And what this means is if you were to run this experiment over and over and over and over, the distribution of the heads are actually going to be approaching this value of 50%. You can actually see it here, how the distribution after a ton of actual trials, it approaches the actual theoretical probability of 50%. So that's what it's referring to the law of large numbers, that on the long run, as n increases, you're going to be approaching the theoretical probability of the event if you run it as an experiment. A couple definitions that you're going to need for events that are asking for gambling. So if you were to have any of these problems on a future exam, I'll give you the formula, same idea. And depending on what they're asking, they could be asking about the odds against the event, odds on favor. Now, odds, you basically express them as A over B, and then express them as the actual notation of the odds, which is A to B. So all of these represent fractions. And then you may have a problem where they're asking about pay of odds in case that you're involving some profit, and that's the actual equation that you're going to be using. Now let's take a look at example 1, and give me just a second. But on some of the problems that they're going to actually ask us to analyze, they're going to be giving us some data, and you're just estimating based on the data given in the problem. So all the problems that are asking for some probability, you're actually going to do the following. So you're always going to declare the event, in this case, let A equal to, and this is a subject being struck by lightning. So a subject getting struck by lightning. Okay, so as you evaluate the probability, you're simply going to say P of A is equal to the following. Now, your entire sample space is the total number of people in the US, and then basically the actual sample that you have in order to do the calculation. So in this case, 390 over, wait, that looks like a 6. 390 over 290. 789,000. Now, all of your problems, you're going to actually express them as a fraction and then as a decimal approximation. So please evaluate that and see if you're matching. So in this case, I'm actually getting that this is point. I have 1, 2, 3, 4, 5 zeros. So 1, 2, 3, 4, 5. And then I have a 1. Or if your calculator is giving you scientific notation, I'm getting 1.34 times 10 to the negative 6. So this is the answer that I want to see on future paper assignments. The software may ask for any of these two. So let me just count the zeros. 1, 2, 3, 4, 5, and the 1. There's actually more values here, but the calculator is giving up. And then in this scenario, it's giving me the solution as scientific notation. So it's giving me this. So this is what I want on any future problem that I'm asking. I want to see your fractions. Don't reduce the fractions. I want to see exactly where you're obtaining these problems, and then it's okay to give me any of these two, whichever your calculator is giving you. Now the software may be a little bit picky because it may say round to 2 decimal places. The most that we're going to get probability would be to 4 decimal places. So in this case, if you were to find one of these problems on the homework, you would just say that that's 0. It takes a little bit on the homework questions because you have to see how exactly they want it, and they may change from problem to problem. So that's it for actually example 1. We're basically evaluating the rules of probability, which in this case, you're evaluating the values of P of A, total ways that A can occur over the sample space. And all of your problems that you're turning in with the probability, the actual event needs to be actually defined. Okay, so let's take a look at example 2. And then in this scenario, you technically have executions. Now they want us to list the sample space. The sample space is all the occurrences of all the events. So in this case, S is equal to, and in this case, I'll just rewrite it as sentences, but we're talking about death sentences. and this is equal to 795 plus the values of 10, so 805. And I'll just leave it as sentences, but it's technically death sentences or executions. And let me just leave it as sentences. As long as you declare or put the units, it's perfectly fine. Some of the problems that we're going to be evaluating, the actual event are pretty messed up things. In this case, we're honestly talking about executions, but it doesn't seem like a proper way to use the unit. I'll just leave it as sentences. As long as you mention some unit on the sample space, that would be perfectly fine. Now, for the next one, they're looking at the following. They want us to find the probability, and it's asking for probability that the following is going to actually occur. So in this case, let me just say let A, and in this case, a female is executed. So a female is executed. Okay, so in this case, the probability of A is equal to, well, your females, you have 10 females out of the sample space, which is 805. So in this case, 10 divided by 805, I'm getting approximately, and I'm going to run it to 4 decimal places. So 0.01, so 0.01, 2422. So depending on what the software want, 0.01, or it could want 0.0124. So the answers that I want are the actual fraction don't reduce, and then the decimal will be fine. So you typically run this to 2 decimal or to 4 decimal places. You only need one of these two. If it doesn't state, choose anywhere between 2 to 4. So let's take a look at the next one. In this case, execution of a male. So I'm just going to say let B equal to a male is executed. Now, for the probability of B, you're looking at the following. Your males were 795. So this is equal to 795 out of 805. So I'm getting that this is approximately 0.9876. So 76 rounding to 4 decimal places, or approximately 0.99. Once again, the actual fraction, and then any of these two, I'll keep it as 0.99 on the final answer, but any of those will be fine. Now, the last question that they're asking, is it unusual for a female to be executed? Now, if they had mentioned anything about the data being bell shaped, you're talking about 2 standard deviations away from the mean, or the complement of that, which is 5%. So that's what it's referring to, this 5% rule that you're going to see here. So you may see that explanation at some of the homework questions. In this case, if the event is less than 5% or 0.05, we'll just say that it's unusual. So on this problem, they're asking, is it unusual for a female to be executed? Since we already declared the variable, you would just say yes. The values of P of A, this is the females, it's approximately 0.01, which is less than 0.05. That would be the only explanation that you need. Since you technically already declare A, here this sentence is reading yes, the probability of a female being executed is 0.01, which happens to be less than 5% or 0.05. So that's one of the advantages of actually already declaring what the variable is. You don't have to rewrite an entire sentence.